This is the Torre Latinoamericana, and the story of how it was built might be the most interesting engineering story you've never heard. To understand why this tower is such a big deal, you first have to understand what's underneath it. Mexico City was built on top of an ancient lake, Lake Texcoco. The Aztecs built their capital, Tenochtitlan, right there on an island in the middle of it. When the Spanish arrived and drained the lake, they built their city on the same saturated, spongy, clay-rich soil that's been compressing ever since. And we mean sinking. When engineers surveyed the site back in 1949, Mexico City was subsiding at a rate of about 20 centimeters per year. Some parts of the city have dropped several meters over the decades. Now imagine being told, we want you to build the tallest building in Latin America on that ground. Oh, and it's also in one of the most seismically active regions on Earth. That's the problem the team behind the Torre Latinoamericana had to solve. And the way they solved it? Genuinely brilliant. The project was commissioned by an insurance company, La Latinoamericana Seguros S.A., who wanted a headquarters that would put Mexico on the world map, and the men they hired were more than up for it. The architectural vision came from Augusto H. Alvarez, a Mexican architect who designed the tower alongside Alfonso González Paulada. Alvarez drew inspiration from the Chrysler Building and the Empire State Building in New York. He was thinking big, bold, modernist, glass and steel, but he also knew he needed someone who truly understood what was underground. That person was Leonardo Zevaert. Zevaert was a specialist in soil mechanics and deep foundations, and he became the key engineering mind behind the project. He immediately understood that the ground wasn't just a construction challenge, it was a matter of life and death in an earthquake scenario. He brought in American structural expert Nathan Newmark, who was essentially one of the founding fathers of earthquake engineering, to help work out how the tower would need to behave when the ground started shaking. This was a truly international team solving a truly unprecedented problem, and the solution they came up with was, in many ways, ahead of its time. The foundation of the Torre Latinoamericana isn't just impressive, it's inventive. Beneath the tower, 361 specially designed piles were driven 33 meters deep into the earth, reaching down through the soft clay to firmer strata below. But here's what makes this genuinely clever. It wasn't just about going deep, it was about how the building would sit on the soil. Zevaert's team drew on the same concept that the ancient Aztecs had used centuries before, driving wooden piles under their temples to act as shock absorbers and dissipate the energy from earth tremors. Thousands of years later, the same principle was being applied to a glass and steel skyscraper. The basements of the tower were left essentially hollow. Why? So they could act like a ship's waterline, allowing the whole structure to sway in rhythm with the ground rather than fight against it. Think of it like this: a tall, rigid tree snaps in a storm, but a bamboo plant bends and survives. The Torre Latinoamericana was designed to be bamboo. The steel frame above, weighing 3,200 tons, was designed to distribute seismic forces through a rigid core and a perimeter frame, avoiding dangerous stress concentrations at any single point. And this steel and glass combination wasn't just an aesthetic choice. The double-glazed glass facade added lightness to the overall structure, while the steel provided the ductility needed to absorb seismic energy without collapsing. The whole thing was designed not to resist earthquakes by brute force, but to move with them. That distinction is everything. Construction began in February 1948. For 8 years, the site was a hive of activity right in the middle of one of Mexico City's busiest intersections. The company that commissioned it had to temporarily relocate its offices to a nearby building for the entire duration of construction. The engineering challenges didn't stop at the foundation. Deep excavations had to be made in waterlogged clay, a notoriously difficult material to work with, without destabilizing the surrounding streets and buildings. The team found solutions for performing deep excavations in clay with high water content and high deformation characteristics, techniques that would later be adopted globally. The final structure comprised 3 basement levels and 44 floors, rising to 134 meters, with a lightning rod on top, bringing the total to just over 181 meters. The building covered a surface area of 27,700 square meters of glass. On April 30th, 1956, the Torre Latinoamericana was officially inaugurated, the tallest building in Latin America and a genuine landmark of modern engineering. A building can look great on paper, but eventually the Earth decides to run its own test. The first came just a year after opening. In 1957, a 7.9 magnitude earthquake shook Mexico City. It was one of the most powerful the region had seen in decades, and the Torre Latinoamericana held, not a single structural failure. The dynamic design had worked exactly as calculated. The tower received an award from the American Institute of Steel Construction, which recognized it as the tallest building ever exposed to enormous seismic force. But the real proof came in 1985, September 19th, 1985. A magnitude 8.1 earthquake devastated Mexico City. Hundreds of buildings collapsed, thousands of people died. It remains one of the deadliest disasters in Mexican history. The Torre Latinoamericana survived without major structural damage, while many surrounding buildings were destroyed or severely compromised. And then, in 2017, another major earthquake struck on the exact same date, September 19th. Once again, the tower came through without major structural issues. 3 major earthquakes, 0 structural failures. The tower is reportedly designed to withstand a magnitude 9 earthquake. At this point, it's not just a building, it's a proof of concept, a real-world laboratory that showed the world how to build in places no one thought you safely could. The ripple effects of the Torre Latinoamericana's construction are still being felt today. The lessons learned during its build were directly incorporated into Mexico City's building codes. Engineers worldwide took note of its foundation design, its structural approach, and its dynamic design methods, and applied them to high-rise construction in seismic zones across the globe. The seismic technology pioneered on this project was the first of its kind in the world, and it continues to be used by skyscraper builders in high-risk zones to this day. It changed how the profession thought about building in difficult places. It proved that geology isn't destiny, that with smart engineering and the right team, you can build tall and build safe almost anywhere. And it did something else too. It gave Mexico City a symbol. The Torre Latinoamericana has stood through decades of change, political turbulence, and natural disaster. It's watched the city grow up around it, and every time the ground has shaken, it has swayed and stood. The story of the Torre Latinoamericana is really a story about what engineering is for. It's not just about aesthetics or hitting a height record or impressing the neighbors. It's about understanding your environment deeply enough to work with it instead of against it. It's about teams of brilliant people taking an impossible brief and refusing to say no. And it's about building something that, when everything goes wrong, still stands. If you enjoyed this video, give it a like and subscribe. We'll be back with more stories from the world of engineering.